Welcome to the second part of the video solving ISC Computer Science Theory Specimen Paper 2023. I have already covered part 1 in my previous video, and in this video I'll be giving a walkthrough of the part 2 of the ISC 2023 Computer Science Specimen Paper, that is section A, B and C. We'll talk of the common mistakes, tips, tricks and strategies along with the best practices. Remember, it's less about just getting the correct answer and more about the thought process and presentation. The focus will be on how to get to the solution rather than relying on memory. Let us begin with the first question. The first question, like always, is on reducing a sum of products expression by K-map. Our first task is to make a grid, then label it. And while labeling, we must pay attention to the order of the variables over here. Like here, the variables are A, B, C, D. So we'll take the variable A, B on this axis and C, D on the other. This is usually followed by labeling the axis. So let's do it. So since this is SOP, this will be A complement dot B complement, then A complement dot B, then A dot B, and finally A dot B complement. On the horizontal axis, we'll have CD. So first we'll have C complement, D complement, then C complement, D, and obviously the dot over here is implied. Then we have CD, then we have CD complement. Then we'll plot the numbers. So it is 0, 1, 2, 3, 4, 6, 9, 11, 13. And since it's an SOP K-map, we'll be filling up 1. So we'll have a 1 at 0, 1, 2, 3, 4, 6, 9, 11, and 13. The next step is to identify the octets, quads, and pairs. In this question, octets are not possible, but we can make quads and pair. So let's see how. So if you notice, we can get one quad over here by rolling up of the K-map. That is, this is one quad. There is another quad by rolling up the map in this direction. So these are our two quads. And then this one can be combined with this one to form a pair. One important point which must be kept in mind is that one should not form a group in which all the constituents are already part of some other group. Like in this case, we are not supposed to combine these 4 ones at the top row to form a quad, because these ones are already part of the other group. Now, once the groups are identified, the next step is to reduce the group. And here again, the notation is very important. Avoid the temptation of making arrows and then reducing it directly. That is not how it is supposed to be done. The correct method is that we'll first write the main term or the max terms using the correct notation, and then we'll proceed on to the reduction step. Let us move on to the reduction step now. So I'll first reduce the quad over here, that is 1, 3, 9, 11, and the correct way to represent it is we use small m and then we say m1 plus m3 plus m9 plus m11. Now we'll say what is changing state. So whichever literal is changing state, that will be dropped. So if I see on the sides, here A complement dot B complement is there, and at the last row it is A dot B complement. So A is changing. Here it is A complement, here it is A. So we'll take B complement. Then at the top we'll see what is changing here. C complement is changing to C, D is same. So this will be B complement dot D. The next quad is 0426 or 0246, whichever way you want to write it. So let's write it. So we'll say M0 plus M2 plus M4 plus M6. Now, if we see on the side, B is changing state, A complement is same. So we'll take A complement over here. On the top row, if I notice, C is changing state, D complement is same. So we'll take D complement. Now we are left with this pair, that is M9, M13. So we'll first write over here M9 plus M13. And this is going to reduce to, let's see, Here A is same, B is changing, so A will remain. And if we see at the top, C complement dot D is common to both, so we'll say C complement dot D. So the final reduced expression of ABCD is A comma B comma C comma D equals, the first term is B complement dot D, then the next term is A complement dot D complement, and finally the last term is A dot C complement dot D. So this is the answer to the first part. Now, the second part of the question, that is question 3.1b, says that draw the logic gate diagram for the reduced expression, and we can assume that the variables and their complements are available as input. Now, let us draw the logic gate diagram for the reduced expression. So this is our expression. Let's move it to the top, and then we'll draw the logic gate diagram for the same. So the first AND gate is having B complement and D. So B complement and D. We'll have an AND gate over here. Then we'll move on to the next one, A complement dot D complement, A complement and D complement. Then we'll have the next one, that is A dot C complement D, A, C complement and D. And then we'll have an OR gate in the end. And do not forget to label it with the character F. So this is the second part of our answer. And now it's time to move on to the next question. And again, following the usual pattern, the second part of the K-map question is on POS. Notice the pi over here. So let's move on to the plotting part first. Before plotting, we have to label it, obviously. So the variables are again A, B, C, D. So we'll take A, B on one side, C, D on the other. Now, since this is a POS, so the labeling will be slightly different. So this will be A plus B. This is A plus B complement. Then we have A complement plus B complement. And finally, we have A complement plus B. On the top axis, we'll have C plus D, then C plus D complement, then C complement plus D complement, and finally C complement plus D. Let's label it. So 0, 1, 3, 5, 6. 0, 1, 3, 5, 6. Then 7, 9, 11, 13. 7, 9, 11, 13, and then 14 and 15. Our next step is to identify the groups. First, we are supposed to identify the biggest group, that is octet, followed by quad, followed by pair. So we can clearly see an octet over here. Let's mark it first. So this is our octet, that is group of 8. Once this group of 8 is done, we'll make a quad over here. Remember, the idea is to form the biggest possible group. And then we'll have one pair over here. Now let us reduce these groups. We'll start with the pair. And here again, notice the notation. Here we'll use capital M's. So we'll say M0 dot M1. And if you see over here, A plus B is common to both, so we'll get A plus B. And if we look at the top, D is changing state, so we'll take C. Then we'll move on to our quad, that is 6, 7, 14, 15. M6 dot M7 dot M14 dot M15. Let's see what it reduces to. Over here, A is changing, B complement is same. And over here, C complement is same, D is changing, so we'll take C complement. So this is B complement plus C complement. And then we move on to our octet. Let's begin. m1 dot m3 dot m5 dot m7 dot m9 dot m11 dot m13 dot m15, and this is going to reduce to all these variables will be removed from the side because everything is changing state on this side, and on top if we notice C is changing state, D complement is same, so this will reduce to D complement. Also, for clarity, you may write over here that okay, this is a pair, this is a quad, and this is an octet. The same thing can be done in the previous question also. So the final reduced expression is f of a comma b comma c comma d equals, we'll have the first term that is a plus b plus c, then the second term that is b complement plus c complement, and then the third term that is d complement. And as usual, the second part of the question is asking for the logic gate diagram for the reduced expression. So let's do it. First term is a plus b plus c. That is, we have a, b, and c. And then we will have three lines going into an OR gate because there's a plus in between. Make sure that all these line touches the gate. So this is first. Then we have b complement plus c complement. B complement plus C complement, and finally we have D complement coming, so we'll take D complement over here, and then we'll take a direct line and we'll have an AND gate, and don't forget to mark it with the label F, and this is the answer to our second part. Now let us solve question number 4, which gives us a set of condition, and based on those set of conditions we have to form a truth table, and finally we have to write the SOP expression based on the truth table. According to the question, a family intends to purchase a smartphone depending on the criteria given below, and the first criteria is quad-core processor with internal memory of 64 GB. That means if you see this table over here, the variable P is for the processor, the variable M is for the memory, the variable R is for the resale phone, and W is for the warranty. So in the first case, quad-core processor with internal memory of 64 GB or more but not a resale phone implies that we are looking for those rows where the processor is 1, the memory is 1, but not a resale phone, that is R is equal to 0. So if we look over here, P is equal to 1 means the last 8 rows. With that we need M is equal to 1, that means the last 4 rows, and with that we need R is equal to 0, which means that we are looking for this row and this row, that is we'll place a 1 over here and a 1 over here. Let us focus on the second criteria now, which says resale phone with quad-core processor but without warranty. So the variables involved in this case are the processor, that is P, the resale phone, that is R, and warranty, that is W. Here P is 1, R is 1, but without warranty means that W is 0. So the only rows where P is equal to 1, R is equal to 1, and W is equal to 0, that is 1, 1, 0 is over here, and 1, 1, 0 is over here. And now is the time to consider the last criteria, which is processor is not a quad core, that means P is equal to 0, with a warranty of 1 year, that is W is equal to 1, and the internal memories of 64 GB, that is M is also equal to 1. So here the first half is P is equal to 0, and then this second portion, that is second part of the first half, is M is equal to 1, and for W is equal to 1 we have this row and this row. So we have 1 over here and a 1 over here. So now our table is ready and the next step is to get the terms. So we'll only consider those rows where we have 1 in the x column. And if you notice over here, P is 0, M is 1, R is 0, W is 1. So wherever there is a 0, we'll take the complement of the corresponding variable. Wherever there is a 1, we'll take the variable directly. So in the first case, we'll get P complement because P is 0, M because M is 1, R complement because R is 0, and finally W because W is 1. So this is our first term. Similarly, the second term becomes P complement M, R, and W. The third term over here becomes P, M complement, R, W complement. Then the next term becomes P, M, R complement, W complement. The next term 1101, that means only the third variable is complemented. So P, M, R complement, W. And finally, the last one is P, M, R, and W complement. So the final answer is supposed to be an SOP expression where SOP means sum of products. We have already got the product. Now we have to combine them by getting the sum of these terms. So we'll say that X is equal to, the first term is P complement M, R complement W. The second term is P complement M, R, W. Then the next term is P, M complement R, W complement. Then the next term is P, M, R complement, W complement, followed by P, M, R complement, W. And finally, the last term is P, M, R, W complement. And this is our final answer. The next question is, what is a half adder? And this has another part to it, and which says that draw the logic circuit for the sum and carry expression of a half adder using only NAND gates. So let us see how we are supposed to do this. The answer to the first part of the question, that is what is a half adder, is relatively straightforward. A half adder is a combinational digital circuit which can add two 1-bit binary numbers. In simple terms, it's a circuit which can add two 1-bit binary numbers. So if we assume that the two 1-bit binary number variables are A and B, there will be two outputs, that is the sum and the carry. The four possible values of AB in this case will be 0, 0, 0, 1, 1, 0, and 1, 1. And if I add 0 plus 0, the sum is 0, the carry is 0. If I add 0 plus 1, the sum is 1, the carry is 0. If I add 1 plus 0, the sum is 1, the carry is 0. And if I add 1 plus 1, we get 1, 0, that is 2. So the sum part is 0 and the carry is 1. Now notice the column for the carry part. It says 0, 0, 0, 1. That is, the output is high when both the inputs are high, which means that the expression for the carry is A dot B. Similarly, if you look at the column for sum, you will see that the output is high when only one of the input is high, which means that sum is equal to A XOR B. Now the second part of the question is asking for only the NAND gate representation. So the question is, what is a NAND gate? NAND gate means AND gate followed by a NOT. That means if there is one X, there is one Y, we'll have one AND gate, and then there is a bubble to denote a NOT. Algebraically, NAND means X dot Y whole complement. So our task is to convert these two expressions, that is C is equal to A dot B and S is equal to A XOR B, into a form so that it is in the form of x dot y whole complement. Let us first convert the carry expression so that it contains only NAND. So the carry expression is C is equal to A dot B. Now this can be written as A dot B plus A dot B. So this is by idempotence law. Idempotence law states that x plus x is equal to x. Note that the word idempotence means same throughout. So here our x is A dot B. So A dot B plus A dot B is same as A dot B. Now the next step over here is that if I add a double complement on the top, that is A dot B plus A dot B, if I say double complement, the value of the expression will still remain the same. Why? Because law of involution states that x double complement is equal to x. And this is very natural also. 0 complement is 1, 1 complement is again 0. Similarly, 1 complement is 0, 0 complement is again 1. And now if you notice, this is and now notice that we can convert this plus into dot by applying De Morgan's theorem to the lower bar. That is, we can say A dot B complement dot A dot B complement whole complement. Why? Because when you apply De Morgan's theorem, this plus will change into dot and the lower bar will be broken into two. The upper bar is still the same. So this is via the De Morgan's theorem. And notice this is in the form of NAND gate. There is A dot B whole complement, there is A dot B whole complement, and then this A dot B whole complement dot A dot B whole complement is actually a NAND gate. So for better understanding, let us draw the logic circuit for C only using NAND gate. So A dot B complement, that is A, B whole complement, is actually a NAND gate. And then the second NAND gate is also having the same input. So we'll take this input, split it into two, and then we'll again have a NAND gate. And this is our C. So this is the individual circuit diagram for C. We'll incorporate this into our sum once we get there. But right now, just for understanding, this is how we do it for the carry expression. So now the carry expression, which was C is equal to A dot B, using only NAND gate, looks like this. The next step is to transform the sum expression using only NAND gate. So let's do it. So our sum expression is S is equal to A XOR B. By definition, A XOR B is same as A complement dot B plus A dot B complement. Now the value of the whole expression is not going to change if I put a double bar over it. That is, if I say this whole thing double bar, by law of involution, that is x double complement is equal to x, the value of the whole expression is not going to change. And like we did in the last question, we can again resolve the lower bar over here, and this will become A complement dot B whole complement dot A dot B complement whole complement, and then there is a whole complement once more. So now if you notice, this is in the form of NAND, but this is not a very good way of doing it. Why? Because the number of gates involved are far too many. So if we count the number of gates used, this A complement will require 2 gates. This B complement will require 2 gates. Then there is one gate over here. There is one NAND gate over here, and then one NAND gate over here. So 4 plus 3, 7 gates will be required to implement this, which is not a very good idea. So we will not adopt this approach, though this will give the answer, but this is a very bad way of doing it. Why? Because it's requiring a lot of gates. So what we'll do is we'll back up a few steps and then we'll proceed again. So let me back up a few steps. So the approach which we'll be adopting is that first we'll get rid of a complement dot b and a dot b complement in this form. We'll convert it into NAND obviously, but in a way such that we don't require those extra gates for doing a complement and b complement. So let's begin. So what we'll do is we can write the same expression like this. We can say plus 0 plus a dot b complement, and the value of the expression is not going to change. Why? Because x plus 0 is equal to x. The value does not change if you say plus 0. Then what we'll do is that instead of the 0 over here, we'll substitute b dot b complement. B dot b complement. Remember, x dot x complement is equal to 0. So instead of 0, we can replace, or rather we can substitute b dot b complement. And similarly for the second 0, we'll substitute a dot a complement, and then we'll just copy down a dot b complement. Then what we can do, we can take b common in the first half and we can take a common in the second half. That is, this will become, b will come out and we'll say a complement plus b complement, and similarly over here a will come out and we'll say a complement plus b complement. Now recall that according to De Morgan's theorem, x dot y complement is same as x complement plus y complement. So if you notice the RHS over here, x complement plus y complement, the form is same, a complement plus b complement. So here instead of a plus b complement, we can say a dot b whole complement, and similarly instead of this a complement plus b complement, we can say a dot b whole complement. And again, if we apply law of involution, that is, we say that b dot a dot b complement plus a dot b complement. That is, I have just copied this line, and if I say double complement the whole thing, the value of the expression is not going to change. And now if I resolve the lower bar over here, that is, I am applying De Morgan's theorem on the lower bar, which means that this bar will be broken and this plus will become dot. That is, we'll get b dot a dot b whole complement dot a dot b complement whole complement, and then the upper complement will remain the same. So the value of the expression is not changing, but now if you notice, everything is in the form of NAND only. So now let us make a logic circuit for the sum using NAND only. So what we'll do is we'll have an A, we'll have a B, and then A dot B whole complement. That is this part. I'm talking about this part over here. So let's do this first. So A, B, and then there is a NAND. Now what happens after this is that we are getting another NAND by combining it with B. That is, I'm talking about this portion now. So what we'll do is we'll take B, and then we'll have one more NAND gate over here. And the same thing is happening on the other side with A. That is, I'm talking about this portion now. That is A dot B complement. And then it is getting combined with A. So we are already getting A dot B complement over here, but now we have to combine it with A. So what we'll do, we'll take this, we'll take one term input from here, and then we'll have one more NAND gate over here. So this takes care of the first half and the second half, and then the final NAND comes over here. That means we'll have one more NAND gate over here like this. And then this is our final sum. Now let us also integrate the carry part which we did earlier. I'm talking about this portion. Now notice a dot b complement, and then we are again doing a dot b complement dot a dot b complement. So this part is already there over here. That is, I'm talking about this first gate over here. What we can do now is we'll take one terminal, one point from here, and then we'll just add one more NAND, and this becomes the final carry. So we have a sum and we have a carry. So this is half adder using only NAND gates. This is our final answer. The next question is asking us to simplify the expression using Boolean laws, and the expression is P dot Q plus P plus Q dot P plus PR plus Q. And although the expression looks complex, but the solution is actually quite simple. We just have to apply absorption law 3 times. Let's see how. So the absorption law is that A plus A dot B is equal to A, and that is why it is called absorption law. B is getting absorbed. Similarly, there's another absorption law which states that A dot A plus B is equal to A, but let's do one step at a time. So here, if you notice this portion, I'm talking about this portion. Here we'll apply A plus A dot B. That means this will be PQ plus P plus Q dot, and this whole highlighted portion will now be simply P, and then we'll copy down Q from the previous step. So this is the reasoning. Now let's move on to the next stage, and in the next stage what we'll do over here is notice this region. I'm talking about this highlighted region. So now if you notice over here, this is also absorption law. That is the dual of the first absorption law. A dot A plus B is equal to A. Here again, the variable B is getting absorbed. So now what we'll do is this expression will now come to PQ plus, and this whole thing will reduce to P. The Q will get absorbed, and then we'll say Q. And now notice once again over here, that is this portion, we can now again apply absorption law. So this will become, again Q will get absorbed, we'll get P plus Q, and again the reasoning is very important. You must never forget to write the reasoning over here. So this is also the absorption law once more. So we'll write the absorption law here also. So A plus A dot B is equal to A. And this is our answer. Let us now move on to the next question, that is question number 5, which happens to have 3 subparts. The first part is, what is a decoder? Now, a decoder is a circuit that changes a code into a set of signals. It is called a decoder because it does the reverse of encoding. The answer for this will be, a decoder accepts n input binary codes and convert them into a corresponding output signal. There are n input lines and a maximum of 2 to the power n output lines. Based on the combination of inputs present, one of the output lines will be active high. The next part of the question is asking, how is it different from a multiplexer? And the answer to that is that decoder is different from a multiplexer due to the presence of select signals, which select one of the several inputs and transmit the selected input signal to the single output. In short, the presence of select signals in a multiplexer differentiates it from a decoder. The third part of the question is asking us to draw the logic circuit for a 2 to 4 decoder and explain its working. So let's do that also. So let's say there are 2 input signals. We'll call them I0 and I1. So we have one line for I0 and we have one line for I1. Now we'll also be requiring the inverted line. So what I'll do is I'll connect a NOT gate over here, and then we'll have one line for NOT. So this is the inverted line. And now what I'll do is insert a NOT gate over here. So we have one NOT gate over here, and I have one NOT gate over here. So if I0 is 0, the inverted line will contain 1, and the same thing will happen for I1 as well. Now we'll be needing 4 AND gates. Let's make them one by one. So we'll need one AND gate over here, then one more, then one more, and then one more over here. One AND gate, the second AND gate, the third AND gate, and the 4 AND gate. Now if you notice, there are n input signals I0, I1, and now there will be up to maximum of 2 to the power 2, that is 4 output signals. So we are just going to take the maximum number of output signal possible. So this is the first output signal, then we have the second output signal, then we have the third output signal, and finally the fourth output signal. Let's label them also. So this is F0, this is F1, this is F2, and then we have F3. Now also notice that we have to explain its working, and one of the way to explain the working is through a truth table. So let's quickly make a truth table over here. Our variables are I0 and I1, and the possible outputs are F1, F0, F1, F2, and F3. So F0, F1, F2, and F3. The possible values for I0 and I1 are 0, 0, 0, 1, 1, 0, and 1, 1. Now what we are trying to do is that when we are getting a 0, 0 as input, we want F1 to be high and the remaining to be 0. When we are getting 0, 1, please understand 0, 1 is 1 in decimal. Then we want F1 to be high and the other 3 inputs to be 0. Similarly, when we are getting 1, 0, that is 2 in decimal, we want the line 2 to be 1 and the remaining to be 0. And in the same way for 1, 1, that is 3, we want the line 3 to be high, that is the line corresponding to 3 to be high and others to be 0. So this is what we are trying to achieve. Now, when I0 is equal to 0 and I1 is equal to 1, we want 1 for F0. F0 is actually an AND gate. In fact, all the Fs are AND gates. So what we'll do is, we know that this is 0, that is I1 is 0 and I0 is 0, and the only way we can get 1 is that if we invert this and put it into AND, that is, we'll connect the inverted lines, that is this one and then this one. So if you notice now, let me make it a thick dot over here to indicate that this is connected, and similarly we'll make a thick dot over here also. So when this is 0, inverted line will become 1, so we'll get 1 over here. Similarly, when I1 is 0, the inverted line will contain 1, we'll get 1 over here, and 1.1 is 1. So F0 will be 1 only when this is 0 and this is 0. Now using the same logic over here, when I1 is 0, I0 is 1, we want the F1 line to be high. So whatever is 0, that input will be taken from the inverted gate, and whatever is 1 will be taken directly. So let's do this one also. So I1 will be taken from the inverted gate, and I0, which is 1, will be taken directly. And do not forget to have a thick dot over here, because there are only two ways: either you make bridges or you make a thick dot over here to indicate the connection. Now the next one is I1 is direct and I0 is through the inverted line. I1 is direct and I0 is through the inverted line. Again, we have to make thick dots. And finally, the last combination is 1, 1. That is, we'll take both the inputs directly. So we'll connect this one over here and we'll connect this one over here. And again, we'll make thick dots to indicate a join. So this is the answer for the third part. The next question is, verify if the following proposition is valid, and our proposition is P implies Q conjunction P implies R is same as P implies Q conjunction R. And we'll verify this by using a truth table of 3 inputs. So let us draw the truth table. We'll have the 3 variables, that is P, Q, and R. In the last column, we'll have false, true alternating, false, true, false, true, false, true, false, and true. In the second last column, we have 2 false followed by 2 trues followed by 2 false followed by 2 trues. And similarly, in the first column, we have 4 false followed by 4 trues. So first we'll have a column for P implies Q. That is this part. The conditional P implies Q will be false when P is true and Q is false. For all other input combination, it will be true. We'll have P implies Q and it will be false only in these two cases. That is, we'll have an F over here and we'll have an F over here, and the rest of them will be true. The next column will be for P implies R. So let's have a column for P implies R. Now here also P implies R will be false when P is true and Q is false. And therefore we'll have a false over here and a false over here. Remaining will be true. So all these are true. Now we have to perform the AND operation on the last two columns. So the next column is for P implies Q and P implies R. So we'll have a true when both these are true, otherwise we'll get a false. So we are getting a true, 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 and true and false is false. So we'll get a false over here, then again a false over here, and then again a false over here, and then finally a true over here. The next column is for Q and R, that is this region. So let's begin. We'll have Q and R. The output will be high when both the inputs, that is Q and R, are high. So we have a high over here and we have a high over here. That is true. High means true. And rest of them will be false. So this is false, 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 this is false. That's it. Now the last column will be for P implies Q and R. We already have Q and R, so now we have to make P implies Q and R. Now again, P implies Q and R will be false when P is true and Q and R is false. Therefore, we'll have an F over here, here, and here, and remaining rows will be true. And now notice that the LHS column, that is this column, and the RHS column, that is this column, are identical. Hence, our proposition is valid. Now, in the next question, we have to write the max term and min term for the function a, b, c, d when a equals 1, b equals 1, c equals 0, and d is equal to 1. So there are 4 variables, a, b, c, and d. And we are interested in that combination where a is 1, b is 1, c is 0, and d is 1. Now we have to find the max term and the min term. Now max term refers to the sum terms, and here when the literal is 1, we take the complement. When the literal is 0, we take it in uncomplemented form. That is, this will become a complement, b complement, c, d complement. And remember, max term means the sum terms, so we'll have plus over here. Now min term is the opposite of max term. That is, here When the literal is 1, we take it in the normal form, and when the literal is 0, we take the complemented form. So going by this logic, this becomes A, this becomes B, this becomes C complement, and this becomes D. Now min term refers to the product term, so we'll have a dot over here, we'll have a dot over here, and we'll have a dot over here. And so this is the first part of our answer, and this is the second part of our answer. With this, the section A is over, and now we'll move on to section B. Questions in section B are programming based questions. The instruction for section B clearly states that mnemonic variable names should be used. Mnemonic variable names refers to descriptive variable names. In other words, avoid single character variable names as far as possible. Do write comments to clarify your logic. The comments must be short and precise. Do not write obvious comments. For example, for statement int c is equal to 0, avoid comments like declare and initialize variable c to 0. This kind of comment does not serve any real purpose. Also pay attention to efficiency when developing the logic. Do not focus only on getting the correct answer. In fact, getting the correct answer is the minimum requirement for any program. What good is a program if it doesn't even give the correct answer? You might have noticed that on this channel, my focus is always on optimizing the solution and using best practices, and not just on obtaining the correct answer. Let us move on to solving the questions now. The first question of section B, that is question number 6, is based on pronic numbers. A number is said to be pronic if the product of two consecutive numbers is equal to the number. For example, 6 is a pronic number because 6 is a product of two consecutive numbers, 2 and 3. 2 into 3 is equal to 6. Similarly, 12 is a pronic number because 3 into 4 is equal to 12. Similarly, 90 is a pronic number because 9 into 10 is equal to 90. And as usual, the program has to be object oriented. They have given the name of the class. The name of the class must be pronic. Data members, there is only one data member, that is num, which will store the number. Similarly, there will be a constructor for getting the, or rather for initializing the data member with legitimate initial values. Then there has to be a function by the name of accept num to enter the number, that is input. Then there has to be a Boolean function is pronic, which will test whether the number is pronic or not. And the main thing is that this function has to be recursive. And then finally, there will be a function by the name of check, which will call this pronic function and then display an appropriate message. We have to define the main method or the driver method as well. Now, it is possible to test for pronic numbers without writing a loop or recursion, but that is a topic for a separate video. Here we'll write a recursive function for is pronic because that is the demand of the question. In order to test an integer for pronic, we must check if the product of two consecutive numbers is equal to the number. The two consecutive numbers can be thought of as either v and v plus 1 or as v and v minus 1. That is, either we can start from 0 and move up, or we can start from the number and move down. Let us understand this with the help of an example. And what I'll do is that first I'll take a number line. So let's say this is our number line. And on this number line, we have 0 over here. And the variable which we want to test whether or not it is a pronic number is represented by the variable num. So we need two consecutive numbers. So either we can start from 0 and move up. That is, we can start from 0 and move up. That is one way of approaching the problem. Or we can start from num and we can move down. So what I'm trying to say over here is that if we are moving up, we are thinking in terms of v into v plus 1. And if we are moving down, we are thinking in terms of v into v minus 1. Now, while learning recursion, you must have encountered functions like factorial and power, where we started from the number and moved down. And that may seem familiar and logical, but computationally, if we try to apply that logic over here, it will be quite expensive. For example, take the example of the number 90. If you start from 90 and start doing 90 into 89, 89 into 88, 88 into 87 and so on, it will take a long time for you to reach 9 into 10, 90. But if you start from 0, then you will reach 9 into 10 fairly quickly. And that's why, for efficiency purposes, we'll start from 0 and then we'll move up. That is, we'll be checking for v into v plus 1 rather than v into v minus 1, because we want our program to run as fast as possible. Now in recursion, the base condition or the exit condition is very important. Otherwise, the program might run till all the resources are exhausted, and we don't want that to happen. So what we'll do is, our exit condition will be if v into v plus 1 is more than the number, that is more than num in this case, then we'll exit from the function. So let us begin with coding. We'll import java.util because we have to enter the number. So we'll say import java.util.tricks, and then we'll have to define the instance variable. So ideally the instance variables should be private for data abstraction. So we'll make it private. So we'll say private int num. That is what the question asked for. Then we need a constructor, that is a public function with the same name as that of the class. And in that we have to assign a logical, or rather a legal value to the instance variable. So inside the constructor, we'll say that, let's say our default value is, say for example, 90. We can keep 0 also, that doesn't really matters. And then we have to define a function to accept the value into the instance variable. And the name of the function given in the question is accept num. So we'll say public void accept num. That's the name of our function. And from within this function, we'll enter our value. So we'll say scanner in is equal to new scanner system.in. Once that is done, we'll display the message to the user. We'll remove ln, we'll just say print, and we'll say enter the value of num. And then we'll have a variable. Variable has already been taken, that is num. So we'll say num is equal to in dot next int. And remember, it's always a good practice to close the scanner object when the job is done. So we'll say in dot close. So this is our accept num method. And now we come to the actual method which will do the job, that is the recursive method, and that will be called as public boolean is pronic. And the variable mentioned, or rather the argument mentioned, is v. So as we discussed, we have to check whether or not the two consecutive values, or rather the product of the two consecutive values, is equal to the number. So we'll say if v into v plus 1, if this is equal to the number, in that case this is a pronic number. So we'll say return true. That is the first case. And then our base condition means that if we go beyond the number, that is, we'll say else if. We can directly say if also, but for clarity we'll say else if. So if v into v plus 1 is more than the number, we are sure that this cannot be a pronic number. So we'll say return false. And otherwise we'll make the recursive call. So we'll say else return is pronic, and this time the new value of v will be v plus 1. So this is our definition of the is pronic method. Now we have to make a function called check, which will actually call the is pronic method and then display an appropriate message. So we'll have the function check, and within check we'll simply say if is pronic, and then we'll give our starting value. The starting value is supposed to be 0. So we'll start with the value 0, and then if the value returned is true, we'll say number is pronic. else we'll say number is not chronic. And now we'll go to main, we'll create an object of the class chronic, and then we'll call these two methods one by one. So we'll say chronic obj is equal to new chronic. This will create an object by the name of obj. Then we'll accept the value by saying obj.accept num. And finally, we'll call the method .check to check and display an appropriate message. Let us run this program and see what happens. So we'll execute the program and we'll enter the value. Let's say 12. 12 is chronic, which is correct. Let's again run it for a different value. And this time, let's say I say 5. 5 is not chronic, which is also correct. So this completes question number 6. Now let us move on to the next question. Now the next question, that is question number 7, is about arranging two single dimension arrays into one single dimension array such that the odd numbers from both the arrays are at the beginning and even numbers at the end. We have to design a class by the name of odd even, which encapsulates the two data members, the array which is to be arranged and the size of that array. Other than that, we are supposed to define 4 functions. One of them will be a constructor to initialize the size, and one function will be known as fill array to enter the data. Then there will be the main function arrange, which will actually take 2 objects of odd even class, merge them into a third object and then return the object. And finally, at the end, there has to be one display function. Also note that we have to design the main functions and call the functions to do the required job. Now, before we move on to the coding part, let us understand the problem in detail with the help of the example which is given. So there will be an object. That object will contain 2 things, the array and the size of the array. And there will be 2 such objects. So I'll just make a copy of this. So now there are 2 objects. And in fact, there has to be a third object for storing the answer also. So this is the third object. So let's say we'll be calling the first object as obj1, the second object as obj2, and let's say the third object is result. The name of the array is a, so this is obj1.a, this is obj2.a, and this is result.a. Plus there is a second data member which stores the capacity of the array, which goes by the name m. Now please understand, actually there is no need to store the capacity, because whenever you say obj1.a.length, you will get the capacity. But since the question is specifically asking us to do it, we'll take a variable m as well. So as per the example, the first array stores 2, 13, 6, 19, 26, 11, and 4. So the size is 7. The second array stores 7, 22, 4, 17, 12, and 45. So the size is 6. The size of the resultant array will be 7 plus 6, that is 13. And then comes the filling of the array. So all the odd numbers are supposed to be at the beginning and the even numbers are supposed to be at the end. So let's start with obj1.a. The first odd number is 13. The next odd number is 19. Then we get 11. Then we move on to the second array. The first odd number is 7. Then we get 17. Then we get 45. And then all the odd numbers are over. And then we move on to the even numbers. So the first even number is 2. Then the next even number is 6. Then we have 26. Then we have 4. Then we have 22. Then we have 4. And finally we have 12. Now the simplest way to accomplish the main task, that is the task of merging two arrays, is that we take 4 loops. One loop for copying the odd elements of the first array into the resultant array, then one loop for copying the even numbers from the first array to the resultant array, and the same way 2 loops for copying the odd and even numbers from obj2.a into result. So that will require 4 loops. But here we'll employ a trick by adding one more variable to do it in 2 loops instead of 4. So that will be a big advantage in terms of the amount of computation required. Now there is one more thing which I would like to emphasize on, and that's a very important point, and that is how to find out whether a number is odd or not. Please note, I'm not saying how to find out whether the number is even or not. I'm saying how to find whether the number is odd or not. What I mean to say is that the expression n modulus 2 equals 1 does not correctly finds out whether or not the number n is even. So this method does not work for negative numbers. Let me explain with the help of an example. Let me show you why and how the expression n modulus 2 equals 1 does not correctly test whether or not the number is odd in case of a negative number. And for that, what we'll do is we'll open JShell so that we don't have to write the complete program. So here comes the JShell, and I'll show you it for an example. Let's say -3. So if I say -3 modulus 2, see what happens. -3 modulus 2 gives you -1. So -3 modulus 2 equals 1 will give you false. And we know that -3 is an odd number. So that's why you can't use n modulus 2 equals 1 for testing whether the number is odd or not. The reason to bring up this point is that the question mentions that integers are stored in the array, which implies that the numbers may be positive or negative. Okay, so let us dive into some code. We need to enter data from the keyboard, so we'll import the util package. The name of the class given in the question is odd even, so we'll call the class as odd even, and then we have to create the instance variable. So private int, we need one array called a, and we need to store the size of the array, and that will be stored in the variable m. That is one thing. And then we need a constructor, so we'll say public odd even, and within the constructor we are told to take an argument int mm, and that mm will be stored in the variable n. So we'll say m is equal to mm. Once that is done, we need to initialize an array, so we'll say that okay, a is equal to new int, and the size will be m. So our constructor is done. Then we need to have a fill array function to actually enter the values. So let's create that also. So we'll say public void fill array, and inside fill array we'll create a scanner object. Scanner, let's call it in, is equal to new scanner, and we'll say system.in. So this will create the scanner object. Once that is done, we'll have to run a loop for the entering of values for the size of the array, which is also stored in the variable m. So we'll say for int I is equal to 0, I is less than a dot length I plus plus, and then we'll get the values from the user. We'll say that okay, a of I is equal to in dot next int, and this will fetch values from the user one by one. So this completes our fill array method. Then we also need one method to display the array. So let's have a display function, public void display, and this display function is supposed to display the entire array. And now since no fancy formatting is involved, we'll simply display it using arrays.toString. That is, we'll convert the array into a string directly. We'll say convert it into an array a. So this takes care of the display method, and now we come to the main part of the program. So we'll create our main method. We'll say public static, and when I say main method, I'm not talking about public static void main, the starting point. I'm talking about the main method in the context of this program, which is arrange. So if you notice, the name of the function is arrange. It is returning an object of type odd even. That is, it will return an object which will contain the array and the size of the array, and that will accept two odd even objects. That is, we'll say odd even p and odd even q. So these are the two objects which will be passed. And now we need a third object, and the size of the third object should be such that the resultant array should be able to hold the values from both the arrays. That is, the size will be equal to p dot a dot length plus q dot a dot length. So we'll say odd even, let's call it result, and then we'll say new odd even, and to the constructor we'll pass the sum. That is, we'll say p dot a dot length plus q dot a dot length. We could have said dot m also instead of dot length, but they both mean the same thing. So now we have the resultant object. The size is also initialized. Now we have to fill the odd numbers in the beginning. So we'll say int front is equal to 0. And now here we'll apply the trick. I don't want to take for loops. I want to do it in as less as possible. Remember, more is not merrier in computer science. So what we'll do is, the trick is, while we are entering the numbers, we'll count how many odd numbers are there. And for that purpose, we'll create one more class variable over here because we want it to be common among all the objects. So we'll say over here, let's say public static int. And what should we name it? Since it is supposed to be the base address for odd number, let's call it base, simply base. So I'll say base, and our initial value will be -1. I'm making it -1 because the array starts from 0, so we have to compensate that value of 1. So I'm initializing it to -1. And now we'll go to the line where we are entering the number, and then we'll check. We'll say that if a of I modulus 2, and here comes the important part, we have to say not equal to 1 for checking the odd number. And if it is odd, then we'll say base plus plus. So let's go to our arrange method and let's have our first loop. So we'll say for int I is equal to 0, I is less than. The size of the first array is stored in m, so I is less than p dot m, I plus plus. And now what we'll do, if it is even, we'll store it after base. If it is odd, we'll store it in front, and we'll be doing it with one loop for the object p and with one loop for the object q. Please understand, since whatever we'll be doing inside for variable q, we'll be doing the same thing for variable p also. So we can make a separate function, but since the question is specifically saying that the arrange method should do the job, so we'll do it inside arrange. So let's check. So we'll say that if p dot a of I modulus 2 is equal to 0, that is, if it is even. If it is even, we'll go to the if block, and if it is odd, we'll go to the else block. And if it is even, we'll transfer it at the base location. So we'll say that, okay, result dot a of base is equal to p dot a of I. And once that is done, we have to increase the value of base, and we can simply say base plus plus over here so that we don't have to write one more line. And in the second case, we'll store it at the front. So I'll just copy this line, we'll paste it over here, and instead of base plus plus, I'll say front plus plus. So this takes care of the transfer from the first object to the result array. Now what I'll do is, in order to save time, I'll copy and paste, and then we'll make p into q. So that second object is also taken care of. And then when everything is done, we'll say return result. Now we have to make a main method so we can create an object and call other methods to get the job done. So we'll have our main method, and within the main method here also we need a scanner object because we need to enter the sizes of the arrays. So we'll say scanner in is equal to new scanner system.in. Then let's display the message also. We'll say system.out.println, enter number of elements, and we have to give this message in double quotes. So we'll enclose it in double quotes, and then we have to create two objects. So we'll say odd even. Let's say a is equal to new odd even, and we have to enter the sizes also. So we'll say dot next int. This takes care of the first input. Then we'll make a into b, and then we'll do the same thing. So the objects are created, and once that is done, we'll call the fill array method on both the objects. So a dot fill array, and then we'll say b dot fill array. Once that is done, Now we'll create a third object of odd even, let's call it C, which will hold the resultant array. So we'll say odd even dot arrange, and then we'll pass the two objects. The two objects are A and B. And the final step is we'll call the display method on the object to see what the answer is. Now we'll run the program for the given set of values. So I'll copy this value from here and we'll paste the values over here. Once the values are pasted, we'll make it, I'll first arrange it properly, and then I'll convert these line into a comment, otherwise the program is not going to run. Now we don't need these commas because I want to copy paste. So very quickly I'll remove these commas from here. And once the commas are removed, let's run this program and see how it's working. So we'll say there are 7 elements in the first array, 6 elements in the second. Then we'll copy the input, that is this set of values, copy and paste. And then we'll do the same thing for the second set of values as well. So copy and paste. And there we are getting exactly the same answer. That is what was required. So odd elements are at the beginning, even elements are at the end, and we are doing it with just 2 loops for the arrange function instead of 4 loops. That's it. Let's move on to the next question. The next question, that is question number 8, is on string. It is asking us to create a class called encrypt, which replace all the vowels by the next vowels in a word. So the important point is that we have to enter a word, that is one thing, and we have to replace each vowel by the next vowel. So A will be replaced by E, E by I by O by U by A. The example given is computer, where O is getting replaced by U and U is getting replaced by A and E is getting replaced by I. The instance variables to be created are WND for to store a word, LEN for storing the length of the word. Please understand this is not actually required, but since the question is asking us to do it, we'll do it. But otherwise, whenever you need the length of the word, you can always say word.length. Now, the next thing is new word, that is to store the answer or the encrypted word. We have to create a constructor to initialize legal values. Then we'll have a function accept word to get the input from the user. Then we'll have the function frequency vowels consonants to calculate the frequency of the vowels and the consonants contained in the word. And then there is a function next vowel, which is supposed to take a character and return the next vowel. And finally, there is a disp function to display the original word as well as the new word. And in section B, like always, we have to define the main method as well. Another important point is that we have to accept a word in uppercase. That is, it is assumed that the word entered by the user is in uppercase. And this simplifies our logic because we don't have to separately check for uppercase and lowercase vowels. So let us dive into the coding part, and we'll start with the instance variables. So private string, we have to create 2 variables, new word and the original word, that is word. Then we have to take the length. Once that is done, we'll move on to the constructor. So public encrypt, and inside the constructor we'll assign legal values into the variables. So word is equal to new word is equal to an empty string, and length is equal to 0. So this takes care of the constructor. After the constructor, we have to have a accept word to enter the values from the user. So public void accept word. Within the accept word, we need a scanner class object. Then we'll enter the word. So we'll say word is equal to in dot next. No need to say next line because we are entering only the word and not the line. And then we'll initialize the variable length with the length of the word, that is word dot length. So accept word is also complete now. And now, since in the frequency count method we have to count the frequency of both the vowels and consonants, we'll create separate functions to make our job easier and the program modular. To we'll make two functions extra, that is vowel to check for vowel and is consonant to check for the consonant. So let's do it. We'll say private string vowels, and then I'll store all the vowels. So A, E, I, O, U. And there is no need to have the small case, but for the sake of completeness, if you want to have it, you can have it. So let's have it. So we have all the vowels stored in the variable vowels, and then we'll have our method to check for the vowels. And check means we'll return a Boolean variable. So is vowel, and the character which we want to check for is ch, and then we'll have a one line function. We'll simply say return vowels dot index of ch. Now note, the variable vowels store all the vowels. Vowels dot index of ch means we are searching for the character inside the string vowels. If the character is found, a value of 0 or more will be returned, otherwise -1 will be returned. So if 0 or more is being returned, this will evaluate to true, otherwise it will evaluate to false. And this has to be static also. Okay, this is done. Now we have to check for the consonant, which will almost be similar to this only. So we'll say public static boolean is consonant. Again, the character which we want to check for is ch, and then we'll say return, and we'll use the other function, but please understand we have only made a list of vowels, not of consonants, and I don't want to do it also. So what we'll do, we'll first check that if character dot is letter, if character dot is letter ch, that is if it's a letter and it is not a vowel. So we'll simply check if it's a letter and not a vowel, then we'll return the value. And we forgot a and operator over here, so let's add it. And not is vowel, so it's a consonant. And now we come to the counting method. So we'll say public void, and the name of the method was frequency vowel consonant, frequency vowel consonant. And then let's count the frequency separately. So we'll have two variables, count vowel to store the frequency of vowel. We'll initialize it to 0. Then we'll have count consonant to store the frequency of the consonant. So we are calling it consonant. And then there has to be a character ch variable to extract each character at a time. Then we'll run a loop for all the characters. So we'll say I is equal to 0, I is less than word dot length, and then we'll say I plus plus. Then we'll extract the character. So this is a common theme in most of the string questions. You run a loop from the beginning to the end, and let me correct the spelling, and then you do something with the extracted character. So we'll say word dot char at I. This will extract character one by one, word dot char at I. Once that is done, again there's a spelling mistake over here, let me correct it. So length is a method. Once this is done, we'll say that if it is vowel, then we'll say count vowels plus plus, and if it's a consonant, we'll say count consonant plus plus. And obviously a character cannot be both a vowel and a consonant, so we'll say else if. Okay, this takes care of the calculation part. Now we'll display. So we'll say system.out.println vowels, and then we'll display the count of the vowels. Similarly, I'll make a copy of it, we'll paste it again, and then we'll convert it, change it into consonant. So this takes care of the frequency part. And now we come to the function next vowel, which is supposed to take a character and returns the next vowel. So let's do it. We'll say public void next vowel. So we'll say char ch. Then we'll again need to traverse. So we'll say int I is equal to 0, I is less than word dot length. Then we'll extract the character. Once the character is extracted, either we can use a lots of if to check for the vowel and replace it by the next character, or we'll use a simple trick. I'll prefer the trick because I don't want to write five if else if for the 5 vowels. So what we'll do is we'll simply check if is vowel ch, that is if the character is a vowel, we have to do something, and that something is we have to replace it by the next character. So I'll say vowels dot index of, and then I'll find out where is that character in the list of vowels. Once we get that character, I'll add +1 to it to get the next character, and once that is done, I'll say modulus 5 so that we get a value from 0 to 4, and then we'll extract this value from the list of vowels. That is, we are first finding the current vowel, then we are adding +1 to it, then we are bringing it to 0 to 4, and then finally we'll say vowels dot char at, and we'll extract the whole thing. And then we have to store it in the variable ch. So we'll say ch is equal to, and now we'll say char to typecast it into a char, and that's it. One liner to do the job. And once that is done, we have to add this character to the new word. So new word plus is equal to ch. Then we'll move on to the next method, which is disp, to display the original word and the encrypted word. So public void disp, and we'll enter both the words. So system.out.println, and we'll say original word, and we'll display the original word, that is wrd. Then we'll make a copy of this line, we'll paste it, and then we'll change original word into encrypted word, and the name of the variable is new word. And then we come to our main method, where we'll create an object and call all the functions. So encrypt, let's call it obj for the object, is equal to new encrypt, constructor called object created. Then we'll accept the word by saying obj dot accept word. Then we'll display the frequencies, so object dot frequency vowel count. Then we have to replace it by the next vowel, so obj dot next vowel. And finally we have to display both the values. So let's see whether the program is working or not. So we compile and run the program, and then we'll enter our value. So the value was computer. We press enter, and we are getting the correct answer. O is getting replaced by the next vowel U. U is being replaced by the next vowel A, and E is getting replaced by the next vowel I. So with this, the section B is also completed. Now we'll move on to section C. The first question of section C, that is question 9, is asking us to create a data structure called holder, where the elements are being added from the rear end and removed from the front end only. Now observe that this behavior is identical to that of a queue. In other words, the question is asking us to implement an array-based queue. Notice that the array used to hold the integer elements is also being referred to as queue. However, there is one important distinction, and that is the initial values of the variable front and rear. Instead of the popular and traditional approach of initializing front and rear with -1, here we are asked to initialize the values of front and rear with 0. In my opinion, this is a good idea as it discourages rote learning. Other than the constructor, we have to define 3 functions: add int to add an element into the queue, and if it is not possible to add an element, we'll display holder is full. Then there is a function remove int to remove the integers from the front end. If there is no element, then we have to return minus 999. And the last method is show, which will display the elements of the holder. Let us now code the holder class as per the given specification. So we'll start with the instance variables. So we'll say private int, the name of the array is q. Then we have to have one variable for the capacity, followed by the front, followed by the rear. So these are our instance variables. Then we need a constructor, so public holder. And within the constructor, we'll initialize the values and we have to accept one integer n to hold the capacity. So the first thing we'll do is that capacity is equal to n. Then we'll say that front is equal to rear is equal to 0. And then we'll finally initialize the array, that is q is equal to new int, and then we'll give the capacity, that is cap. So this completes our constructor. Then the next method which we are supposed to design is public void add integer to add an integer to the end of the queue. So the name of the argument is v as given in the question, and then we can only add if the value is less than, that is if the value of rear is less than the length of the queue, then we can add, otherwise we have to say holder is full. So let's check that condition first. So if rear is more than or equal to q dot length or capacity, whatever you want, if it is more, then we'll say that holder is full. So holder is full. Otherwise we'll add, so we'll say else, and adding is actually relatively straightforward. We'll say add it at that place, so is equal to v. However, we have to increase the value of rear once we have added the element, so q of rear plus plus is equal to v. So that's how the add integer function will work. Once that is done, we'll move on to the next function. The next function is supposed to be remove int. So public int remove int, that's the name of our method. Now the default value should be 999. That is, if we are not able to read anything, the default value will remain minus 999, and that will be returned towards the end. So in the end, we'll return the value, whatever the value is. By default, it is 999. Now we'll check that if rear is equal to 0, that means the rear is pointing to the first element. So if that is the case, we'll say holder is empty. So holder is empty. That's one case. Now, if that is not the case, that is else if front is less than cap, that is if front is less than capacity, we can remove. So we'll go towards the end and we'll say that, okay, let's take out the value. So we'll say value is equal to q of front plus plus. Note that we are not actually removing the value because that is not possible. We'll just read the value and modify the front or the rear. So this is the case. And this takes care of the remove int part. Now we have to define one more function, that is show. So we'll say public void show, and then we'll simply take a loop from front to rear and display all the values in between. So for int, I is equal to front, I is less than rear, I plus plus, and then we'll say that, okay, system.out.print, not println. We'll say q of I, that is, we'll print the element and then we'll give one space for clarity, and then when all the elements are printed, we'll display one blank line. So system.out.println without any arguments. So from the examination purpose, this is what we want. But here I want to run the program to show you that it is working for all the possible cases. So let's make a main also. In exams, you don't have to make a main. So public static void main string args, and then we'll create an object of the holder. So we'll say that, okay, holder obj is equal to new holder, and then we are supposed to give a size. So let's say we want the capacity to be just 3. Now we'll add 3 elements one by one. So obj dot add integer, and let's say we are adding first 0, then we'll add 1, then we'll add 2, and that makes it 3 elements. So we are adding 0, 1, and 2. And then we'll call the display method to see what is inside. So if I say obj dot display right now, we should get 0, 1, and 2. Sorry, not display. The name of the method was show. It was display in the previous questions, not in this case. So if I run the program right now, I'm getting 0, 1, 2, which is correct. Now, please notice there are 3 elements. The capacity is 3. If I try to add one more element, I should get the message holder is full. So let's try to do that also. So I'll copy this, paste it over here, and we'll run it once more. And there we are getting the message holder is full. So this is also working. Now we'll comment out this last line and let us remove all the elements one by one. So we'll say that, okay, obj dot remove int, and we'll call this method multiple times so that all the elements are removed. And while we are removing it, we'll print them also. So let's say I say system.out.println, and then I say obj.remove int. There are 3 elements, so I'll give 3 removes. So 1, 2, 3. So if the remove int is working properly, it should remove out first 0, then 1, then 2. So let's run it. So there we are first removing 0, then 1, and then 2. Now there is one more thing left to be tested, and that is what if I try to remove the element after all the elements are removed. So if I run this program once more with one extra element being removed, please note there are 3 elements and we are trying to remove the 4th one, and now we are getting minus 999. So this completes the first question of section C. The second part of the question, name the entity described above. The entity described above is actually a queue. So the answer is queue. And state its principle. Here the principle is first in, first out. Now let us move on to the next question. That is question number 10, which is from the chapter inheritance. In this question, there are 2 classes, the bank class and the interest class. The bank class is assumed to be created. We don't have to create it. We only have to create the derived class, that is the interest class. The base class bank has 3 data members, name, account number, and principal. There are 2 methods. First one of them is a constructor which will initialize the value. The second one is the display method which will display the instance variable values. In the derived class interest, we have to add 2 instance variable, the rate and the time. The rate stores the rate in decimals, the time stores the time period in decimals. Again, in this case, there are 3 methods. One of them is a constructor which will initialize the values of both the classes. That is, this constructor will take the values of these 2 instance variables plus these 3 instance variables from the base class or the superclass also. Then there will be a calculate method to calculate the compound interest. And then finally, we'll have the display method, which will display the values of both the classes, that is the base class as well as the derived class. Also note that the superclass main function and algorithm need not be written. So now let us dive into some code. The question said that assume that the bank class has been defined. So here it is, the bank class has already been defined. Let's have a quick look at it. There are 2 private data members, name and account number. The third instance variable principal is protected because we need it in the derived class for calculating the compound interest. The third data member, that is principal, is defined or declared as protected because we want to access this in the derived class. The constructor is accepting the required arguments and initializing the instance variable with those arguments. And then there is a display method, which is just displaying the three data members. Now let us move to the actual coding. So we'll say class interest extends bank. Then we'll create the data members, private, float, rate, and time. Then we'll create the constructor of the derived class, that is public interest. And this constructor is supposed to initialize 5 things, out of which 3 will go to the constructor of the base class. So we'll just copy those 3 things from the constructor of the base class, and then we'll simply paste it over here, and then we'll add the remaining 2 things, that is float rate comma float time. Now in order to call the base class data members, we'll be needing super. So we'll say super, and then we'll pass those three things, that is the name, the account number, and the principal. These 3 things will be passed to the constructor of the base class, and then the remaining 2 things, that is the rate and the time, will be initialized directly. So this dot rate is equal to rate, and this dot time is equal to time. So this completes the constructor. After the constructor, we have to create the calculate method. So public double calculate, and calculate method will simply call the formula. So the formula was principal into math.pow 1 plus rate divided by 100 comma time, and then we have to subtract the principal from that. So we'll say principal once more. So this takes care of the calculate method. And finally, the last method was display, public void display. From within the display method, we'll call the display of the base class to display the instance variables declared in the bank class, and then we'll add the other values from here. So public rate colon rate, then time colon time, and finally we'll say compound interest colon, and then we'll simply call the calculate method to calculate the compound interest. Now the main method is not in the question, but we'll make the main method right now to see whether the program is working or not. So interest obj is equal to new interest. Let's pass on some values. So instead of null, I'll pass the name. So let's say the name is Vinay. Then instead of account number, I'll pass, let's say 1, 2, 3. Instead of principal, I pass 1000. And instead of rate, I'll pass 10. And in place of time period, I'll say 1. Once that is done, I'll call the display method, and display method will call the calculate method from within. And let's correct the spelling, INTEREST. Let's run the program and see if it's working or not. And there we are, the program is working. And this completes our inheritance question also. Now the next question, that is question number 11, part 1, is from linked list. The question is asking us to create an algorithm or a method to insert a node at the beginning of an existing linked list. The structure of a node has already been defined. The node contains 2 data members. One is the number which is to be stored in the linked list, and the other is the reference to the next node. Let me first illustrate the logic before we write the code. So let's say there is a reference variable by the name of star ptr, which is pointing to the first node. The first node will contain 2 parts, the data part and the next part, and the next part will refer to the next node, and similarly the next part of the second node will refer to the third node, and so on. And let's say the third node is the last node, hence the next part will point to null. Now what we have to do is we have to create a new node. Let's say the reference variable is new node, and this will be pointing to a new node. We'll first store the data, that is n over here. Then we'll make the next of the newly created node point to the current first node. And finally, the last step will be we'll break this link and the start will point to the newly created node. So the first step is create a node. Second step is store the data. The third step is change the next pointer. And the fourth step is change the start pointer. Let's try to write the code for the same. Name of the class is node. So we'll say that node, new node. You can call it temp, p, q, whatever you want. Node, new node is equal to new node. This will allocate memory for the node. That is, this will create this portion. And then the reference variable will be stored in the variable new node. Once this is done, we'll store the data inside. So we'll say that new node dot num is equal to n. This n which is passed is being stored in the reference variable num. That is the second part. Third part is adjusting the next of the newly created node. So we'll say that new node dot next is equal to the current start pointer, that is star ptr. And finally, the last step is to make the start pointer point to the new node. So we'll say that, okay, star ptr is equal to new node. Now, the most important part. Here our assumption is that the memory is available. There is a possibility that this new operation might fail, and in that case we must tell the user that okay, the overflow has occurred. So if you want to take that into account also and write a better program, what you have to do is you'll have to enclose this in a try block. We have to say try, and the exception which is thrown when new fails is out of memory exception. So we'll catch it by saying out of memory error. That's what they call it, out of memory error. And if it is thrown, we'll say system dot out dot println overflow. And this takes care of our insertion of a node at the beginning of an existing linked list. Now we have reached the last question of the question paper, and the question is, they have given us a tree and they are asking us about the in order traversal of that tree. We have to name the children of the nodes B and G, and we have to state the root of the right subtree. Let's do it one by one. Now there is a trick which you can use to traverse the tree without any errors, and the trick is you start moving around the tree like this. And whenever you go from under a node, you display the node. So right now we are going under node D. So we'll say D. Then you keep moving on around the corners. Now we are under B. So we'll display B. Then we'll keep on moving. Now we are under A. So we'll display A. Similarly, we'll move forward. Now we are under F. So we'll display F. And then we'll keep moving. Now we are under E, so we'll display E. And then we go under G, so we'll display G. And then when you go under H, you display H. And now we are not going under any element, so we'll simply finish over here. Now this idea can be extended for pre-order and post-order as well. Now please try to understand the idea. The general structure of the node is this. every node has a parent, left child and the right child. So we already discussed that when you are moving below a node, that is for in-order traversal. Similarly, when you are moving on this part of the node, that is for pre-order traversal, and when you are moving in this part of the node, this is for post-order traversal. So let's say if we want to traverse the same tree in pre-order, the first element which we'll get, let's do it once more. So the first element which we'll get is A, the next element which we'll get is B, then the next element is D, and then nothing will happen. When you reach F, then F is the next node, then G is the next node, then E is the next node, and finally H is the next node. The same idea will be applicable if you are doing post, but then you have to do it while you are returning. So like if I do it again, let's say I use a different color pen. So for post order, nothing will happen, then nothing will happen, then again nothing will happen. But when we move from this point, we'll display D, then we'll display B, then nothing will happen in this region, then we'll display E, then we'll display H, G, F, and A. So this trick can be used for all the three traversal methods. Let's move on to the next question. The next question is, name the children of nodes B and G. So if you notice over here, the node B has only one child, that is D, and node G has two childs, that is E and H. So this is E and H. The last part says, state the root of the right subtree. So right subtree means this subtree, and the root of right subtree is F. So the answer will be F. And this question completes our ISC 2023 specimen paper of computer science. In conclusion, attempting a specimen paper is an excellent way to prepare for an examination. It helps you understand the exam format, identify your weakness, become familiar with exam conditions, and boost your confidence. Thank you for watching, and I hope this video has been helpful. Good luck with your studies. Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. You can follow me on the internet on any one or all of these channels.